Because there is a finite or limited, that's what that means, limited amount of fossil fuels left, we are trying to find alternative energy sources. As we discussed in the previous lesson, our fossil fuels are traditional, aka non-renewable resources. They will go away, and when they go away, we won't have any energy because they won't come back for millions of years. So, and the only way to continue to have energy is if we have these alternative energy sources, and that's what we'll be looking at now. So first of all, just think about as many alternative energy sources as you can think of. I'm sure that you probably have a couple coming through your mind because you probably looked at this in middle school. So the first one, before we get to the first one, the alternative resources that we try to look at, they are going to be clean and renewable, because the problem with fossil fuels is they are non-renewable and they lead to a lot of pollution. So if we are trying to replace them with something else, we don't want to replace them with something that is also non-renewable or that's going to give a lot of pollution. So we have to find something that's clean. We need to find something that's renewable so we don't run into this problem again. But there are complications to all of the resources we've found so far, and that's why we haven't completely made the switch. And so we'll look at some of that today. So true or false? Non-renewable resources take millions of years to form. That is true, because remember, they technically come back, but it takes millions of years. The first one we're going to look at is biofuel. And if you remember, the prefix bio means life. So when we look at biofuel, we're talking about fuel that comes from a living thing. They're going to take plant material and animal waste. So yes, they can even take, I've seen some places where they'll take cow manure and they'll turn that into gas for a car, which is pretty cool. But they will use the process of fermenting the biomass in order to turn it into a gasoline that can be used to drive the car. Now, if some of you may be thinking, well, they ferment grapes and they ferment yeast in order to make alcohol. Well, this is a different type of process. It's similar, but they're not doing the same thing. So you cannot just get plants or animal waste, or you can't get alcohol and pour it into a car and expect it to work. You'll just ruin the engine if you do that. But that is what we get. Biofuel is coming from your animal waste or your plant material. There are pros and cons. So just like with fossil fuels, you need to know pros and cons of all of these. So the pros, it reduces the greenhouse effect, because the greenhouse gases, one of the big ones is CO2, carbon dioxide. That's what's been causing so many issues leading to global warming. And so if you are using plants in order to do that, it's not giving out carbon dioxide, so it helps with global warming. There's a large potential supply. We can grow a huge field full of grass or whatever it is that we need to use. But also some places have been looking into using algae that they get from rivers and lakes and turning it into biofuel. And then, like I said earlier, there are some farmers who have sold the cow manure, which is typically a huge waste issue and pollutes the water, and they use that cow manure in order to turn it into biofuel. So that's very cool. And it has the potential of being cheaper over time. Now, there will be a large upfront cost, because everybody have to get a new car that uses this new engine, and they'd have to convert all gas stations into a different type of station for biofuel, all that type of thing. But over time, it has the potential to cost less. Some of the negatives, the cons, it doesn't store well. It doesn't store very long. So we go through gasoline and oil very quickly. And so if we are using the biomass, we have to find a way to make sure it doesn't, I guess you could think of like expire by the time we need it. So it doesn't store very well, which causes a huge complication. Cost of production in order to make a bunch of new cars and gas stations would be very expensive. And then some people are concerned about the amount of fertilizer that people would use to grow the biomass because of eutrophication that it could lead to. Or they say it would lead to a shortage of space and food. Because if we start using the limited space that we have on the earth to grow more plants for biofuel, then that leaves less space for farming, less space for homes, less space for industry, things like that. And then the last one, it does not have as much energy in it as gasoline does. So if you have gasoline, I'm just making up these numbers, but say your car would get 100 miles on that gas, the same amount of biofuel may only get you about 50 miles. So that's one of the issues that they are trying to work on. Geothermal. Now, geothermal, geo means earth. So, and thermal, heat. So this is using the heat of the earth in order to get energy. The main place that we have heat is going to be from the core and the mantle. This specifically is going to use the mantle that is heating up groundwater. So just like we have aquifers, remember those storage places of water, sometimes those aquifers can become very, very warm because they are so close to a magma supply. And that's what's going on here. So that magma is going to heat the water, creating steam. And if we release that steam in the right way, we can use the steam to turn a turbine, and that will power a generator, therefore giving us energy. So that's how geothermal energy works. Let's look at our pros and cons. Pros, it's available 24/7. So it's very reliable. You can get it any time of day, any day of the week. It also is free. The earth is going to be heated in the mantle whether we want it to or not. We don't have to pay for anything in order to have that happen. And then it releasing the steam creates no greenhouse gases, so it's not going to pollute anything. The downside, however, this is only available in geological active regions. So if you don't live in a place that has a lot of activity in terms of faults and volcanoes and hot springs, you're not going to be able to use this. So it is reliable because it's 24/7, but you just can't get it anywhere on the earth. It's going to be really good for places such as California or like Yellowstone where they have a lot of activity. And it's also not inexhaustible. The wells that we use, they tend to be used up within 10 to 15 years. Now, the wells can replenish themselves because of rain. Rain will infiltrate the ground to refill the wells, but it can take a while, and you never know what the climate will be like. And the last con is the cost of drilling. It can be extremely expensive to drill down into extremely hot rock. So you do have to be mindful of that as you are creating these wells. This is just a map of the U.S. showing you the geothermal resources, places where that activity is more likely. And so if you look at eastern North Carolina or just North Carolina in general, it's not very active. So we're not going to be able to use this resource. But again, out west, so anywhere over in this area, they are going to be a great area, or even like right here, in order to use these geothermals. Florida, they have no chance. They have no activity going on, so this would not work for them. But other places, it would be a great resource. This is a video that you can or that you will need to play, and there's a couple questions about the video as you watch it. So there is a video questions page. That's what this is referring to. So you will watch this video and fill out their very short answers to the video questions that will be linked on Canvas. So again, watch this video. As you watch the video, fill out the questions, and that will happen for each alternative resource that we look at. And we will not play Past the Hot Coal because we are not together in class, unfortunately. Okay, hydroelectric. If you were thinking hydro, hopefully that makes you think water. This is one of the types of energy that is created by the release of water. Hydroelectric specifically is when water is released from behind a dam. So you have the dams that block water, they act as a storage device and a flood control method. But if you lift the dam, so you can see over here, they open the gates, and as this water flows down, it can spin a turbine in order to power a generator in order to give you energy. So falling water is what's turning the turbines, and falling water is what's the key here. The U.S. currently gets about 5% of its energy from this, so we are using this method some, just hopefully can start using it more often as we can. So let's keep going. The pros and cons. Pros. Hydroelectric has a very long lifespan. There's no carbon dioxide emission, and it can double as a flood control method. Once you build one of these dams, it's going to stand for a very long time, so you don't have to do a lot of maintenance on it. Not going to release any pollution, and it can serve two purposes at once, which is pretty awesome. Negatives. Dams are very expensive to build, so you're going to have a big cost factor in there. And dams are going to mess up ecosystems. When you have a dam or any structure that people build, it's going to mess up the organisms that live around there. So your little fishies that live in these areas, they're going to be sad because they're not going to be able to move around like they used to. It's also very hard to find a location elevated enough. If we go back to this other slide, you can see how this dam is elevated. It's because the water, again, I told you the key word was falling. that water has to fall to turn a turbine. And so the different levels in the water, it needs to be pretty exact. And that because it's so specific, not every dam can be used as hydroelectric. And here's your video in order to watch to understand hydroelectric a little more. And don't forget to answer your questions. Our next energy resource is nuclear power. Now, nuclear power, I have a lot of opinions on this. It can be really great, but it can also be very dangerous. And so we'll look at that in just a minute. But the fuel for nuclear power is an element called uranium. Uranium is a very unstable element, which is what makes it perfect for this. And they use nuclear fission, which means they split the atoms. So because uranium is already very unstable, it can easily get split. And whenever you are breaking or combining atoms, that takes a ton of energy and releases a ton of energy. So as they split these atoms, it releases a lot of energy that we can use. And it currently is going to produce about 10% of the energy that we have. So there are a lot of nuclear power plants already in the U.S. and around the world, even though we may not think about it very much. Now, the pros is it's going to release so much energy. This could potentially solve all energy issues very, very, very quickly because of the amount of energy it releases. It does not release any carbon dioxide, so no greenhouse gases, so it does help with global warming. And once you have the plant up and running, it doesn't cost much to keep it going. However, it's very expensive to build the plant, but once it's up, the cost is low. Now, one of the negatives for this, all of them are very big. One being the radioactive waste. The waste that comes from once you've produced your energy, the leftover uranium that you have, it releases a ton of radiation. That's what we mean by radioactive. So it can cause cancer, mutations, all sorts of health risk, and can poison you. This waste it will remain radioactive for thousands of years to come. So it takes a long time for this radioactiveness to go away. What they typically do is they will get that waste and they will bury it underwater in order to help prevent the radiation from seeping out. But one of the big downsides is now you have all of this radioactive waste that's just sitting around. And so that's one reason why the waste is a really big issue. You also can have a meltdown. So Japan had a tsunami that broke the seawalls and caused a radioactive meltdown that released a ton of radiation around Japan and was a really big issue. Now think about all the ones we have in the U.S. This is basically the potential for giant bombs to go off if anything happened to them with all of your natural disasters or your warfare, things like that. And the other big downside is uranium is not renewable. So again, we are going back to a non-renewable resource. And if it can't come back, then once it's gone, again, we'll be left with having to figure something else out. However, I do want to bring up that not all nuclear power plants are the same. This is the type of power plant that is most often used now, but people like Bill Gates, for instance, have been funding research that can actually use up the radioactive waste from these power plants and make new energy with it. So that would solve a lot of the problems. They're also a lot safer. They cost a lot more money and can end up being a bit more renewable. But those are not the ones that we are currently using much right now. So there's potential there, but there's a lot of risk factors in figuring things out. Here's your video to watch on nuclear, and then you'll have your questions to answer with it. True or false? Renewable resources are a main form of energy consumption. That answer is false. Our main type of energy consumption is our fossil fuels, which are all non-renewable, okay, the traditional energy sources. Solar energy. Solar energy comes from the sun. So solar power, that is you getting your energy from the sun, which is awesome because the sun is the ultimate form of energy for the earth anyway. And so you use solar panels to get this energy. And you can have one giant solar panel, and we'll look at this a little bit more in a second. Or you can have all these different individual solar panels that reflect light to one area. But again, we'll look at that more in just a second. So how does this work? Well, you have your solar panel that takes in the energy. And one thing that it can do is boil a fluid making steam, and that can turn a turbine. So that's one method. Or the solar panel will turn the sunlight into energy directly itself. If you're interested on how on the earth that can happen, there's a video right here. But it's using the things that we've watched from plants doing photosynthesis. We tried to use that same concept in order to create these panels. When you see a field such as this one up here, sometimes these are mirrors that reflect the solar radiation to one area that then boils a fluid to turn a turbine and whatnot. Your panels like this, or what you see on like calculators, it's not boiling fluids. It's just turning it directly to energy. So your pros, solar energy is free. The sun is going to shine no matter what. The sun is not releasing any pollution, and we don't have to have extensive power grids. That's what makes it really good for developing nations. If you create a power plant, then you have to have all of the grids and the lines that go and move the energy, that electricity from one place to another. With solar panels, if you can put them directly on a house, you don't have to have any grid at all. You just have to have the panel. And that's going to be really good for some of those more poor nations. The negatives, solar energy is not evenly distributed around the earth. Remember, what place on the earth gets the most direct solar radiation? The equator. So anywhere on the equator is going to be the best candidate for your solar energy, or for the solar panels. Anywhere on the poles, because they get indirect light, they aren't getting as much energy from the sun, and therefore their solar panels will not create as much energy. So they won't be as effective there. Also, it's not always sunny. For instance, at nighttime, you have no sunlight. Or if it's a cloudy, rainy day, you don't have as much sunlight as you would. And so your energy needs are not constantly going to be met. And it's very expensive to get the solar panels. It's not very expensive after that, but the initial purchasing is expensive. Another negative is we do not currently have a way to store solar energy. They've been working on creating batteries and trying to fix this problem, but as of this moment, we don't have a very effective way in order to keep that energy to use on your cloudy days or at nighttime. So here's a picture of some developing nations that have some very poor rural areas where people have gone on and they've given solar panels to them in order to create electricity. So you have like a hut that has a solar panel on it. So you don't have to have those grid lines going from major cities way out to these rural areas in order to give them that energy. This one I thought was really cool. They have a solar panel that's powering a pump. So if you live in an area where you don't have good access to clean water, this is a way that they can get year-long access to it. So just thought that was a pretty cool thing. Here's your video on solar, and don't forget to answer the questions that go with it. Tidal energy. This is another form or another way that water can give you renewable energy. But instead of hydroelectric, where you have falling water from behind a dam, tidal energy is using the force of tides. Now, if you remember, the force that creates tides is the gravity from the moon and the sun, with the moon giving the biggest amount, or having the biggest effect because it's closest. And don't forget about your spring and neap tides. This would be a great time to review some of that if you've forgotten it. So basically, when you have the tide coming in, it turns the turbines, and then when the tide goes back out, it continues to turn the turbines, and then that powers a generator and gives you electricity. The pros is that tides are very consistent. Because the moon is constantly going around the earth and the earth is constantly going around the sun, we know the exact time of day that we will have tides. We know when the high tide will be, when the low tide will be, and whatnot. So because tides are consistent, we can predict the amount of energy that we would get. They also don't release any pollution. The downsides, however, again, you are building a dam, and anytime we are building something, we're going to disturb the habitat and the economy, not the economy, the ecosystem. And so that's one of the negative things about it. The other thing is it's very hard to find a place. So kind of like hydroelectric, there's a very specific guideline to how high the dam has to be. That's what we see going on here. You have to be able to build a dam going across the area where the dam or the tide will go in and out a certain distance. And that's a very hard place to find a location that has those very specific requirements going on. So that's one of the big downsides, and one reason we don't use it a lot. Those got my emails. Here is your title video for you to answer your questions with. And our last energy resource that we will look at today is wind. So wind energy uses wind to directly turn a turbine to power a generator. In about 10 years, theoretically, we could have 10% of the country's electricity all met from your windmills. And that would be, I know 10% doesn't sound like a lot, but that would be a pretty big chunk, which would be very cool. So here's a picture of a wind farm that's what they call them for some reason, but this is a wind farm that I saw when Doug and I were on our way to Virginia Beach, leaving Greenville, and I just thought it was really cool to actually see them in person. And this is just to give you an idea of the height and the size of the windmills. People, when you see the pictures like here, they may not look that tall, but they are quite large, and if you're actually up close to them. So one of the good things about your wind energy is it's very efficient. Since you have wind just directly turning the turbine itself, there's not a lot of middleman, so you got a lot of energy coming from it. There is no carbon dioxide that's going to be released from these windmills, and they're very easy and very fast to build, and it doesn't cost a lot to build windmills. The negatives, though, is it's not always windy. You need to have very steady winds, and this is one reason why they make the windmills so tall, or the wind turbines. The taller they are, the more they're going to be in the wind that is just constantly moving, kind of like your jet streams as currents of air that keep moving all the time. Or not all the time, but more often. That's why they build them so quickly, because trees and whatnot aren't interfering with the wind. Sorry about all these pop-ups that keep coming up. So you don't always have steady winds. Sometimes it's going to be more windy than the other days, so you won't get as much energy on those not windy days. But also, windmills give a lot of noise pollution. If you picture the noise that comes from static electricity, but picture it being incredibly loud in your ear at all times, that's what your wind farms sound like. And that's very, very bad. They call that noise pollution because it's harmful for the environment. It would drive you mad. There are instances where they've done these wind farms near agriculture areas, and they have literally driven the cows insane because the noise has been so bad. Then another downside is they kill birds. And as you have, these tall wind turbines in these really high regions or currents of air, those are the same currents of air that your soaring birds, such as eagles, fly in. And they will go, those currents will lead them directly into the turbine, and then that can kill them, which has a big impact on the ecosystem and whatnot. There is a movie on Netflix. It's called The Boy Who Harnessed Wind, and it's based on a true story. That is a very good movie. But there is this guy who actually built his very own wind turbine when there was a huge drought that was causing famine to occur. And he got a book, and he couldn't go to school, but he got this one book, and he ended up building a turbine to power a well that saved the entire village that he lived with. And this is on Netflix, or it was, but The Boy Who Harnessed Wind, I highly recommend you watching it. And here are two other videos. The wind energy video, this is the one you need to watch in order to answer your questions. This is a video that talks about how it's killing birds. It's it's just a short news clip where they're interviewing people about the thing killing birds, and so it's interesting. And if you click on this link just for a second, this just is the sound of a wind turbine. So if you're curious of what it sounds like and how loud it is, turn your volume up really loud and listen to it and see how long you can stand it before you go crazy. But that's what those two videos are. So watch this one for sure and answer the questions. These two are just really good informational ones, or just fun fact ones that I recommend you watch. Okay, and so this chart is a little bit out of date, but this is just giving you about the averages of the energy percentages we use for each. So biomass, almost 3 of our energy comes from that. About 3% for hydropower, 0.3 for geothermal, 0.1 for wind, 0.1 for solar, about 38 for oil. And this is another big deal for you to know. Another name for oil is petroleum. And I forgot to mention that earlier. But when you hear petroleum, that's the same thing as saying oil. Okay, and then you have natural gas and coal, or uranium about 10%, and propane, which is another form of gas, 1.7. Now this is out of date because right now alternative energy is a very big thing. So every single year, the numbers for this is changing. How far we've gotten in technology is changing. It's a very current thing going on. So if you're interested in it, this would be a great way, or a great job, a research opportunity if you want to do that, because it's a very big deal at this moment. Okay, this is a video called for a sustainable city. This would be very cool for you to watch. It's basically talking about how China is considering building its first forest city. And you can see it has the buildings with trees on it. That's to help get rid of carbon dioxide and whatnot, because China is known for having very dirty air. 2 years ago, or it might have been 1 year ago, we had intern students from China come in, and when we asked them what's one of the neatest things from America, they said they couldn't believe how clean the air was. So they're talking about building these cities with trees to help get rid of that dirty air, and would use geothermal and some other things. You can watch the video, and then at the end of the video, it just shows some of these are jokes, like this this bicycle right here, but it's just talking about things that they're doing in order to help clean the air. And it's got face mask this is a joke, but some fashionable face mask that Chinese people will use in order to because the air is so dirty. But I do recommend watching this. It's very cool to see some of the towers and whatnot that they are using, and just the concept of it's really cool. But let's see. That's it in terms of renewable energy. Now I'm just going to show you a couple review questions, and I'll pause for just a second to see if you can answer them in your head. If I'm going too fast, then please just pause the video. Okay, so what are stars made out of? Okay, what gases are stars made out of? The answer is, I don't have the answer. The answer is hydrogen and helium. So our stars are made out of hydrogen, helium, and dust. That is the answer from Unit 2. What theory talks about star and planet formation? That answer would be nebula theory. This is how the bodies of our solar system were created. And what's in our solar system are stars and planets. What star is in the middle of our solar system? Hopefully you know this one, and I don't need to pause too long. That would be the sun. The sun is the big star in the middle of our solar system. How does the sun transfer heat? This is going back to Unit 3 with our heat transfer. The answer would be radiation. And that radiation is using your electromagnetic waves. Okay. And that is it for our alternative energy. And I will go ahead and end this video.